Lesson 9, Causal Relationships. So, as a review from Lesson 1 of this unit, the terms explanatory variable and response variable. So, if we're using one variable to help us understand or predict the values of the other variable, that first variable is called the explanatory variable, and then the one whose values it predicts is the response variable. And when we go and create a graph with these two variables, which we've been doing, the x variable is what we use for the explanatory variable. So we put that one on the x-axis. Sometimes that's maybe time or something. This is also known as the independent variable. So in science experiments, we talk about that, the independent variable. And then the y variable is the response variable. And we would call that the dependent variable. We have the word variable. So, two variables are associated if values of one variable tend to be related to values of the other variable. Sometimes instead of associated, we might say they are, I'll say AKA, otherwise, or also known as correlated. We might use the word they're correlated if the variables tend to be related. And of course, what we learned in our last lesson, we can determine the strength of that association or the strength of that correlation from the correlation coefficient, R. You can review that in your lesson 7 notes. Now, a new term, two variables are causally associated if changing the value of the explanatory variable causes a change in the value of the response variable. So we're going to look at some examples of that to see if we can determine some causally related variables. This is a really important theme of this lesson. Just because two variables are associated doesn't mean that one variable is causing the other. So association doesn't imply causation. Sometimes they're both associated and they're causally associated, but sometimes they just happen to be associated, and we'll look at some examples. So in these practice problems, for each of the following statements, you're going to use the language in the statement to determine whether the statement implies causation or just indicates association without causation. We're going to keep in mind when we look at these statements that determining which one of these it is has nothing to do with whether or not you think the statement is true. Okay, so here is a statement. If you study more, your grade will improve in the course. So let's think about what the explanatory variable is and the response variable. Well, the one that explains, so let's look at our definition. Explanatory variable is using one variable to help us understand or predict the values of the other. So we would use time spent studying. That would be able to predict, the amount of time you study would be able to predict your grade in the course. And then we're going to use this little hint here to decide whether it's causation or just plain association. Would changing the explanatory, I'm missing a word there, the explanatory variable influence a change in the response variable? If so, there is causation. So, let's see, if we change the amount of time studying, would we see a change in the grade someone got in the course? And according to this statement, yes. So this would be causation. So the next one, want to lose weight, drink tea. So explanatory variable would be, and I would pause the video, see if you can do these two on your own, take an educated guess. The explanatory variable would be the whether you would be drinking tea or the amount of tea you drink. and that would influence your weight, how much weight is lost. Now, keep in mind, we don't have to agree with this statement. In fact, I don't think there's really any scientific evidence that I've heard about that drinking tea helps you lose weight. So we're not evaluating the truth of it. We're just seeing how the wording is. So the wording does imply causation, because it says that if we change the amount of tea we drank, that would result in a change in the amount of weight loss. So that would also be causation. Okay, last one. Aging of the brain tends, this is an important word, to be delayed in people with a college education. So there's ways that brains age and lose neural mass and don't make connections as well. And that's why when people get older, they have a harder time with memory. And you can measure how much the brain has aged. But that tends to take longer in people, according to the statement, in people that have had a college education. So the explanatory variable, and see if you can figure this out on your own, is the education, how much education someone has got, whether they went to college. And then the response variable would be the age of brain, or brain age. Now here, because of this word tends, it's not saying that the college education is causing a delay in brain aging. It's just saying that it's associated. This one would just be association. And we're going to come back to this question here in a minute when we define a confounding variable. So a third variable that is associated with both the explanatory variable and the response variable is called a confounding variable. And so now let's go back to this one and think about what is a third variable that might influence both of these things. And we're going to draw a little picture here. We're going to say education is associated with brain age, how much your brain has aged, whether you have a college education or not. The dotted line means association. But there might be a third thing that's actually the thing that is causing both of those. You might have, for example, people that get a college education might have jobs that require more intellectual engagement, which is proven to delay brain aging. If you have an intellectually engaging or stimulating job, or maybe you really like playing word games or learning new things like new languages or music. So we might say something about engagement in mental tasks or something. That might, people who enjoy and do lots of engaging in mental tasks might be people that are more likely to go to college, get a college education, and would also be delaying their brain aging. Or maybe another confounding variable might be wealth. And that is true. People who are wealthier may, actually I don't know if that's true, but they may have a delay in brain age for various reasons. Okay, and then this is important here. Observation studies almost always have confounding variables because they are not controlled. Only controlled experiments can show causation. We'll talk about, we have a definition of those types of studies here later in the notes. All right, let's do some more practice. There is a very strong positive association between cell phones per person in a country and the life expectancy of people in that country. Actually, I'm going to put this in a second video because this video is getting a little longer, so I'm going to